Hi and welcome to WB channel and we do math today. Today I brought you guys a limit question, a limit at infinity actually, and limits are pretty interesting and that's what we're going to do today. I pass the video by the question yourselves and check if you're right. Start solving. One thing we know is 1 by infinity is equals to 0, or I could say tends to 0, and if we are talking limits we can say it's 0. It tends to 0, 1 by infinity. So I'll try to convert everything in terms of 1 by x, and my x is infinity, so I'm gonna turn this into 1 by x. Limit x tends to infinity. I'll take the x squared common in here. So what I would have is 4 plus 3 by x minus 7. That is 7. And here I'm gonna take x common. 7 by x minus 3. And the next step would be this is going to come out of square root. This is going to be 4 plus 3 by x minus 7 by x multiplied by 7 by x minus 3. Okay. I cannot cancel this x because this is minus 7. Then I do it there is multiply and divide this 7 by x. So I would have square root of 4 plus 3 by x minus 7 by x by x into 7 by x minus 3. Now we can cancel out the x's in numerator and denominator. So now what I have is limit x tends to infinity and square root of 4 plus 3 by x minus 7 by x by 7 by x minus 3. Tend everything to infinity. This would give me like 7 by infinity is going to be 0. So I'm going to have 4 plus 3 by infinity is 1 by x tends to 0. So 3 into 0 is 0 minus 0 by 7 by infinity. 7 by infinity, 1 by infinity tends to 0. So I'm going to have another 0 minus 3. This is nothing but root 4 by minus 3. Root 4 is 2. 2 by minus 3. So the limit is minus 2 by 3. There's always another method. Since we had like infinity by infinity form right here, we could say we could use L'Hopital's rule. L'Hopital's rule is another pretty neat method which you can always use, like infinity by infinity, 0 by 0. I avoid using it, because it's just differentiating the numerator and denominator separately and then substituting the limit. It works, but it's kind of like a shortcut. It's not the actual way of doing limits. So I avoid doing it unless it's really necessary and always helps. Yeah, it's trustworthy. I'd say that. And a bonus part, we have limit x tends to 0, 1 by sine x minus 1 by x. This is what? Let's see. Let me substitute 0, 1 by 0, minus 1 by 0. Makes no sense. This is infinity minus infinity form. Not so good. You can pause the video and try it yourselves. It's up to you. What I'm going to do is split. We can do one thing here. We can split this into 1 by sine x minus limit x tends to 0, 1 by x. 1 by. Now I'm going to multiply x and divide by x. 1 by x, right? We multiplied x here and divided by x here minus limit x tends to 0, 1 by x. So, okay, before I write the next step, I should explain something, right? Limit x tends to 0, sine x by x is 1. We can prove it. I'll do a video on this in the latest episode. And also there's another thing, limit x tends to 0, tan x by x is also 1. Limit x tends to 0, cos x is also 1. Yeah, these are the things that we are going to do. We can extend this like sin x by x to x by sin x, which is also 1. I can rewrite this as limit x tends to 0, 1 by x minus limit x tends to 0, 1 by x. But if I write it back like as a whole, I can see limit x tends to 0, 0, and that says my overall limit is 0. But the limit for just x tends to 0, 1 by x is infinity. It does not exist. It's up because you see, we can substitute values for this. However small you go, like 0.1, 1 by x is going to be 10. 0.001, I'm gonna have 1000. So the closer I approach, the closer I approach to my 0. I mean, this is like 0 positive. I'm approaching from left side to positive. I mean, these values are for 0 positive. And if you go from 0 negative, you're going to have like, this is going to be minus infinity. So, however, the closer you approach 0, the larger the number is going to be. The larger negative or larger positive, which is positive infinity or negative infinity. So just for this, the limit does not exist, we say, but in the question that we had, they got cancelled, so we can say the limit is 0. That's the thing, and I will do a future video on these. Like how do we get the limits of sin x by x, tan x by x, and cos x to be 1, 1, 1, and all. Thanks for watching the video, and I hope you enjoyed it. Doubt or something, you can always comment down below. Leave a comment below, and thank you for watching.